Hey everybody, it's Mrs. Casil. I'm going to go over Jasmine's Day of Adventure, assignment 9 for STEM physics. I'm going to do what we did in class today and give you the hints that you need to help with your homework. Remember to pause, rewind, fast forward, whatever is going to help you, and use the tools in this video to help you get your work done. So, our best friend Jasmine is riding her bike around town. She leaves her house at 1 p.m. to go to her friend Keisha's house, but her bicycle isn't working quite right. So she goes to the bike shop located 2 kilometers east and 3 kilometers south of her own house. After getting her bike fixed, she goes to Keisha's house, which is located 5 kilometers from the bike shop in a direction of 20 degrees south of west. Later in the afternoon, she leaves Keisha's house and goes to the store to buy some milk before returning home. Her displacement from Keisha's house to the store is shown as a directed line segment or vector in the diagram at the right, meaning this arrow over here is exactly lined up with and the right length for Keisha's trip Jasmine's trip from Keisha's house to the store. So here's the things that you're trying to figure out, right? You're trying to figure out where is the bike shop. I would definitely recommend you start with that. The second thing you're trying to do is figure out where the store is located. That's very easy to do. And then the last thing that you're trying to do is figure out where is Jasmine's home. And pay attention to the map. That's not Jasmine's house, that's Keisha's house. So you don't know where Jasmine's house is. You need to find it. So first thing, we're going to tackle where the bike shop is, and we're going to use this clue up here that's about that she went from the bike shop to Keisha's house in a direction of 20 degrees south of west. So we have to understand what our compass rose means in order to figure out that exact direction. So anytime you see just the arrow and just the letter N, they're telling you that the direction that arrow is pointing is north. I always draw out the rest of my compass rose because I make mistakes and it helps me make fewer mistakes if I have a diagram there to help me. So I've got north up, south down, east to my right, west to my left. So I'm trying to look in the direction of 20 degrees south of west. So this direction is west. This direction is south. So that line that says 20 degrees south of west means that I'm looking west and turning 20 degrees in the south direction. So I'm going to use a protractor to measure a 20-degree angle precisely, because that's going to give me an exact line pointing south of west. Now ask yourself, is that where the bike shop is? Is it somewhere over here on our map? No, it's not. She went from the bike shop to Keisha's house. She ended at Keisha's house. She started at the bike shop, which means Keisha's house is at the end down here, and the bike shop is going to be somewhere over here on this side of our map. All right, that's where we're looking to find the bike shop. So you need to grab your trusty handy-dandy protractor, and we're going to use that to measure the angle. Magic, I have a protractor now. Okay. So here's how I'm going to use my protractor. So first, I'm going to line up the vertex of my protractor with the front door of Keisha's house, because that lines up nicely on my grid. I'm going to pretend that's exactly where Keisha's house is located. I'm going to need to measure an angle that's pointing in the southwest direction. So I'm actually going to use my protractor upside down. If that doesn't bother you, good for you. If it does, turn your paper right side up, or upside down, I mean. Not a focus too. So I'm lining up my protractor with Keisha's front door. I'll line up my horizontal line. So this 0 line is going to line up with my east-west line as exactly as possible. This is 0 degrees, so I'm looking up and I go to 10 up to 20 degrees right here. So I know that if I have a line that lines up with those 2 points, that is at a 20-degree angle south of west. And I also know that the bike shop is not down here. It's up here somewhere because she started the bike shop and then went south of west to get to Keisha's house. How far did Jasmine have to go? Well, our scale in the bottom right corner says that 1 centimeter on our ruler equals 1 kilometer in real life. Our clue says she went 5 kilometers. So I'm going to draw a line that goes 5 kilometers. It goes up here, and it does not quite make it to the vertex of those 2 points. That's okay. It doesn't have to line up with the lines nicely. Nothing bad is going to happen that it's in a slightly different location. It turns out things exist off the grid sometimes. So now we know this is where the bike shop is. So high five somebody nearby you if you figured that out. Okay, so that's where the bike shop is. The other 2 things, Jasmine's house and the store, you can figure out using the clues that are here. I'm not going to complete those for you. The one thing I will say is that on the bottom down here, they ask you, what was Jasmine's displacement? Displacement is change in position. So when we want to figure out what a displacement is for an object, we have to figure out where did it end up and subtract where did it start. We'll learn how to do that more scientifically next week. But for right now, think about the whole story problem. Jasmine returns home and she left her house at 1 p.m. That's the start of our story. If you were Jasmine's parent and you said, hey, you're grounded, don't leave the house, when you get home from work, you can't tell that she went anywhere because where she ended is the same as where she started. That means her displacement is 0 kilometers. Down here, you need to write your own explanation for why that's true. Number 3, how far did Jasmine actually go? Her bicycle definitely traveled some miles. Her feet definitely traveled some miles. Figure out that total distance she traveled on foot or on bicycle as she went about her day. So that's my clues for the front. On to the back. So we've got a couple things here. Here's my hint I didn't give you in class. This is all cattywampus and at an angle for a reason. Isn't that annoying? Like, how do you work it with a graph at an angle? You don't. Just turn your page. There you go. Now it's square and rectangular. I like that much better. So this is all water. And then down here, this is all land. Right? So there's a couple things that are going on in this problem. First, we have a nice little storyline right here. I'm going to read it first. Bathing on her bicycle, Jasmine decides to lead a life of piracy. Leaving her home far behind, she sails her ship along the coastline from its original position, shown on the map, point X, to Lighthouse Bay, point Z. Along the way, the ship stops to picnic and pillage for an hour near a beach located at point Y. So you've got 3 points on your map that the ship is stopping at, but your problem asks you to do several other things first. First, it asks you to find the displacements from X to Y, from Y to Z, and from X all the way over to Z. Remember, displacement means take where you ended and compare it to where you started, which that happens in a straight line. Imagine if Jasmine's pirate ship could fly. She could get to the same place just by virtue of flying over land, because where she started and where she ended is the same. So if she threw you off the ship right here at point X because you attempted to raise a mutiny and you took one of the flying lifeboats and just went zoom, you would end up in the same place as the ship that was perhaps traveling around by water. Same thing as we travel from point Y to point Z. If it was that you got left behind after the picnic and you're like, shoot, I better march through the jungle here so I can get over to Lighthouse Bay, you would have the same change in position even though you took a different path than the ship going around by water. And the last segment it asks you to look for is the total displacement from X to Z. Let's say not only did you attempt to raise a mutiny, but you drank the last cup of coffee on board, and Jasmine decides that that's grounds for very, very serious abandonment on this piratical coast. But you go, I know we're going to Lighthouse Bay. I'm not being left behind for the next trip. And you walk all the way through the jungle to point Z. Different path than the ship, same displacement as going around by water. Okay? So those are the line segments that it's talking about that you need to compare just the start and the end for X to Y, Y to Z, and your net displacement from X to Z. So, just like on the front, how you were given clues of different types, arrows already drawn, directions of how far west and how far south to go, directions that were a distance and an angle, you're asked to come up with some descriptions here. Horizontal and vertical component means how far in the X direction, right, left and right, versus how far in the Y direction when we're thinking up versus down. Those are, that says down in case you can't read my writing. So those are the things that you are looking at here, and you can use your grid to count those, measure them with your ruler. Make sure you pay attention to the scale when you do so. The last little bit of this, you're going to need to measure the length of your line segments. Again, you're using your ruler or your protractor, and then the direction where you need to measure an angle. If you don't have a protractor at home, then save that part and finish that when you come to class. That's not a big deal. The last thing is you need to draw your path of how did Jasmine actually travel by sea and figure out what's that total distance that she went around the water. You need to describe how you estimated that total distance traveled. I would draw it and then think about how do you turn that into a number at the end. All right? Good luck, everybody. See you tomorrow.